My name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. So today we're talking about the volume of a rectangular prism. So the way I learned it was to apply the formula. So first, we would need to identify that it is a rectangular prism. And you can tell that because we've got two rectangles here, one there and one there. And so it's a rectangular prism because it's a 3D solid with two rectangular faces on each end. So the formula is that, which I just memorized when I was in school, is length times width times height. So I would just plug and chug, as they say. I'd say, okay, looking at my kind of my end rectangular face, that's 4 times 2. And then the height, if you will, is 6. So 4 times 2 is 8. 8 times 6 is 48. So my volume is going to be 48. And we're in centimeters here. So it's going to be centimeters cubed, which we write as centimeters to the third power. Okay, John, what approach should I think of going forward?
So I think that is the tried and true approach when it comes to this topic. And I think students, when asked to find volume, length times width times height is usually the first thing they think of, regardless of the shape. But if we want to be consistent with having one volume formula for any type of prism, we can use what we've discussed in some of our other videos. That volume is really area of the base times the height. We could think of it from a slicing standpoint, that if I take this shape here, I could essentially like slice it up into many of these rectangles, and I'm choosing to go this way, but I could really stack them whichever way I want. But if we look at it as like a slicing and adding them up type situation, we would just need to find the base area, any one of those faces. The area would be 8 centimeters squared for any of these rectangles. And then we want to just sequence them out all the way across the 6 centimeters to the last one. and that would create a 3D solid for us. So we would make our H6 then, because if we stack them all up, that's how high it would go, 6 centimeters. So the volume would be 8 from finding the base area times 6 for the stacking, if you will, for a grand total of 48 centimeters cubed. Now you might ask, why would you make it harder? If they know length times width times height, well, why would you do it this different way? And I think it just reinforces the idea that students, regardless of what type of prism it is, they have to stop, identify the base, what shape is it, and then they can calculate the volume from there, because they usually make mistakes on the other types of prisms. So if they have a mechanism for going in and really breaking down the shape into individual sides, it'll help them find the correct volume.
I see. So anytime they see a 3D shape, they should kind of pause and say, okay, does it have, what shape is on each end? And that identifies, and that informs what the uppercase B is, and then they can just use that times H, and they're golden.
Yep.
Perfect. All right, I'm ready.
Okay, let's do another one.
Okay, so this is our next problem. And you'll notice there's a lot of 3's involved in this problem. So it's a 3D solid. There's another 3. And I'm looking at these faces. And this is a rectangular prism. It's a certain type. It's a cube because every side is the same length. So this is kind of an exciting example. What I'm going to do is I'm going to say to myself, okay, I need to calculate the area of the two faces. So that's a rectangle, or in this case, a square. So 3 times 3 is 9. So the area of this face is 9 feet squared. So now I'm going to go over here to my volume equation, because in math and in life, it's helpful to remember what you're looking for. I'm looking for volume. So my uppercase B is going to be 9, which I just calculated. And then the H is this other 3 here. So it'll be 9 times 3. So it's going to give me 27. And I'm in feet here. So it's going to give me 27 cubic feet for my cube. All right, John, any thoughts?
I think we should point out that it actually doesn't matter which side you make the base when it comes to a rectangular prism. When there was a triangular prism, there's only really two triangles. So that kind of like settles it. Like, that has to be the base, and that's that. But with a rectangular prism, you really can pick anything. So the way that you did it, you chose to use the right side and the left side as your base, and then the length was, what the distance between the two this way. But I could have said that I wanted my base to be, say, this top part here, which was also 3 times 3. And then I might want my height going this way, which is also 3. So there's a couple different equivalent ways that we could do it. And also, when we multiply things out, just to tie in an older video of ours, when we do the 9 times 3, that was 3 times 3 times 3. So that grouping, gave us the 9 times 3, but we could also group it as 3 times 3 times 3 if we wanted to. Like, we can always move those parentheses around regardless of
that's true even when the numbers aren't the same.
Right. So I don't think it's, imperative on this example, but it just reminds me of the associative property we've discussed earlier of multiplication, that you can prioritize certain products first. So I'm thinking, like, if your numbers are like 10, 7, and 2 or something like that, you might want to do 7 times 2 first, regardless of where they are, then multiply by 10. Or vice versa. Maybe you want to do 2 times 10 first and multiply by 7. So you can decide how you want to multiply.
That's the beautiful thing about math, is you get the right answer either way.
Yep.
All right, wonderful. Thank you so much. This is a great approach. So thank you so much for tuning in. We're Math Videos for Parents. Please subscribe to our YouTube channel and like our Facebook page. If you have any problem requests, don't hesitate to reach out. We look forward to hearing from you. Thank you so much.
Take care.